Welcome back to Heroic Physics, the show that uses superheroes and the occasional science fiction reference to help you understand physics. And this episode, we are going to showcase the different types of forces. This is what happens when you don't have a budget.
Justice!
Talk about the dramatic entrances.
Yeah, it's better than your last week's episode with that wannabe superhero, the Arrow. He really wasn't doing your show the justice it deserves, so I thought I would drop by.
Since you all hail Batman, you can help showcase forces today.
I'll showcase these forces with the justice it truly deserves.
Well, don't get ahead of yourself, Batman. There are many different types of forces.
Like the force of justice.
This is gonna be interesting.
Come on, let's go. But inconspicuously through the window.
Well, that's one way to let gravity do the work. I'm just going to take the stairs. Let's define a force in a physics context. A force is a push or pull, or a traction or repulsion between objects with mass, or charge. Now, these forces will cause the objects to change their state of velocity. And do you know what a change of a state of velocity is referred to as?
Well, Boy Wonder, it's acceleration.
Yes. Now, there's going to be 7 main types of forces we're going to be talking about today. Can you name the 7 types of forces?
We got justice force, the force justice, forceful justice. Don't even get me started about the force of injustice. There's just forces galore, and we got some more in there, but we gotta be forceful with it. You know, you just gotta force it down. So yeah.
Those are great examples, Batman, but not the types of forces we're talking about
What?
today.
Oh, alright.
If we're not using the force of justice or the force of injustice, what kind of forces are you describing there, Boy Wonder?
We're going to be using the forces described by physics, not heroics.
Is your show called Heroic Physics?
Yes, because we're using heroic people like yourself to describe physics, not physics to describe heroics.
Well, with this physics, can I have it with the side of justice?
Who knew superheroes would be so difficult to work with?
What is physics?
Okay, Batman. Physics is...
Not you. Alfred?
Other here, sir.
Oh, right.
I am here, sir.
What is physics?
Physics is the fundamental science studying matter, energy, and motion.
Batman out.
I should have taken that position at the Queen's residence. I'm sure their boy didn't grow up to be a troubled child playing dress up.
No. So these physics forces.
Yes.
What are they?
Okay, there are 7 of these forces we're going to be talking about described by physics. Firstly, we have the applied force. Then we have the tensor force, the gravitational force, the normal force, the frictional force, the electric force, and the magnetic force.
So these forces. Let me guess. Is the applied force when you apply a force to an object?
Yes, actually.
Ah.
The applied force is when one object will make contact with a second object. When this object makes contact with the other object, it will cause the other object to accelerate due to the first object applying a force to the second object. So if I had the ball and I take my foot to go to kick the ball, when my foot makes contact with the ball, it's going to apply a force to this ball. This applied force will cause the ball's velocity to change, accelerating due to my applied force, such as this.
The bad app's going off. Gotham needs me.
You're even slower than the Flash.
Do you see that goon down there? Alfred gave me a crash course on the forces on the way over here. What kind of force do you want to use on that guy?
Applied force.
Oh, let's go apply force to the goon!
Justice View, apply force. Another one! Up there!
Boy Wonder, you ready?
The tensing force is a force that acts on an object, such as a rope, that is being pulled on both sides. Right now, Batman is hanging on from this rope, which is also attached above on the ledge. Now, the tension on this rope will want to return the rope to its original length, so it's pulling upwards on Batman as the rope tries to become the length it was originally before Batman was pulling on it.
What is this tension acting against?
In this situation, the tension is pulling against the force of gravity, which tries to pull you back down. The tension in the rope acts as a force against gravity, holding you up so you don't come falling down to the ground. It cancels out gravity, and when the forces cancel out, we refer to it as a state of equilibrium.
So what's stopping me from falling to the earth? Boy Wonder.
In this case, the ground. When you let go of the rope, the tension force is no longer pulling up on you against gravity pulling you down. So you're no longer in equilibrium, and gravity is now on the poles, pulling you down to the surface of the earth. But when you hit the ground, you don't keep going. Gravity's still acting on you, but something stops you. You don't go through the ground. The ground actually applies a force onto you up against gravity and put you back into equilibrium. This force from the ground is called the normal force. A normal force is an upward force from a surface that is perpendicular to that surface and acts against gravity or other forces pushing our object against that surface. When you were falling, you were accelerating, but as you hit the ground, the force from the ground, the normal force, causes you to decelerate, and your speed is now 0. As a result, you stop, and the normal force of the ground keeps you from going through the earth.
Sure sounds like you have constant acceleration there, Boy Wonder.
It's constant until you hit the ground.
Then when it's ground, then even when you're 0, it's still constant.
There's a small time frame where you're decelerating, so your speed returns to 0 because the ground opposes gravity, and you once again return to equilibrium. At equilibrium, all forces cancel out, and you're no longer accelerating upwards or downward.
I got a reading on the Riddler's location. To the Batmobile.
Riddler, where are you?
Well, thank you, Sam. Good thing there's a frictional force.
Gosh darn friction.
Friction is a force between two surfaces, where one is the surface that another object's moving on. When you have two objects that are moving against each other, they don't want to slide. We call it friction between them, where eventually the friction between the objects of the different surfaces contacting each other will slow down any motion of the object, such as a rolling Batman, until they come to a stop due to friction. I think you left a message for us in these equations.
You are wrong, Batman. You'll never find me. I will.
What about this one?
Where does one hide that is open? Where is one enclosed when free?
Holy doorways, Batman! There's still two more forces we need to show them, Batman.
Talking about the electrical and the magnetic.
Yes. The magnetic force is a force between objects that have polar poles. Now, magnetic objects have two poles, a north pole and a south pole. The similar poles, or like poles, north and north, or south and south, will repel each other. Like when you're playing with Thomas trains and you put them facing each other, they'll repel away. But when you have opposite poles, north and south, they will attract each other and magnetically pull themselves together. When you have the Thomas trains lined up together, you can see this in any type of magnet.
Such as this?
Is that a refrigerator magnet?
No, it's a bat scanner. You know I'm a bat?
Yeah.
It resembles my sonar. So it basically tells me where everyone's at.
Okay.
In a nutshell.
Okay.
A bat nutshell.
Okay.
Bat shell. Alright. But we're good. My device just told me we're good.
It's electronically locked. This device shows that the door is positively charged and the wall is negatively charged. We'll leave it to the questioner of questions to do something so electronically shocking.
The electric force is the attraction and repulsion of electrically charged objects. The two types of charges are positive and negative. Like charges repel, opposites attract.
Like criminal cats and justice-carrying bats.
Sure. So, if we want to get this door open, we need to make the door negatively charged so it could be repelled from the negatively charged wall.
But how?
Holy electrons, Batman!
Yes, Boy Wonder.
The negative charge comes from subatomic particles called electrons. So if we were to add a bunch of electrons to this door, we can make the door negatively charged. And then, if the door is negatively charged, it will be repelled from the negatively charged wall.
Science.
Indeed. Physics.
Especially. I got just the device.
You do?
I got a bat electron holder, and it has an excess of electrons. So if I go, I added extra electrons to the door, which will make it open.
Looks like this is the Riddler's hideout, Batman.
Oh, Batman, I knew you would come. I knew for sure you wouldn't bring the Batmobile, though. Now, prepare to be called in my riddle. Riddle me this.
But not today, Enigma! What force? Gravitational force! Normal force!
Hail, Batman!
Thanks, Boy Wonder! Frictional force! Tension! Electric force! Yes! Magnetic force! The force of justice!
Who the heck is this?
Don't worry about it. I'm the Batman.
Well, that's one way you can review forces, Batman, right? He's just gone. Well, come back next week for another heroic episode of your favorite heroic physics show. Same bat time, same bat channel.
Justice! Subscribe! Justified, Lee subscribing.